Okay, so let's look at completing the square. So completing the square is a particular method that we use for rewriting a quadratic equation. And there are a few reasons why we would want to rewrite a quadratic equation in this form. It tells us a lot about the graph of the function. It tells us a lot about the maximum and the minimum point, the kind of what we call the turning point of the function. It can also help us see the nature of the roots a lot quicker than we might see it from a normal quadratic and things like that. It can help us kind of find the roots a little bit quicker. There's a lot of different scenarios where we would want to write something in completed square form. And the key thing with completed square is what we're trying to really do is write it in terms of a perfect square. We want to have a perfect square. So generally what we have is we have a perfect square part, say in the middle there, and we might have some sort of constant at the end. Okay, because it's not a perfect square in and of itself and we're kind of creating one, there generally is a little bit of a constant added on at the end as well. The A part there is if there's a leading coefficient, because completing the square, the first thing we need to do is make the leading coefficient 1. And if it's not, we need to factor out the coefficient that is there. So looking at our steps here, we factor out the coefficient of x squared if it's not 1. We divide the x coefficient by 2, so we divide it in half. We then square that answer, and we add and subtract this to the equation. Now the reason we add and subtract it is to ensure the equation stays balanced. So we're ensuring the equation stays balanced. So we obviously can't just add something to an equation for the sake of it. So by adding and subtracting it, we're ensuring it stays balanced. Now what we're trying to do by halving that x coefficient and squaring it is we're kind of manufacturing a perfect square of sorts. So if you think of something like x squared plus 4x, okay, say we've x squared plus 4x. In order for that to be a perfect square, I would want to have plus 4 at the end here, because then I can rewrite it as x plus 2 all squared as a perfect square. So that's essentially what we're trying to do. We're trying to manufacture this perfect square a little bit. So we isolate the perfect square and then we multiply across by the leading coefficient if there is a leading coefficient. Okay, so there's a fair few steps involved, but it is the same steps all the time. Obviously, it's important just that we get used to those steps, that we know what those steps are. And the key thing with completed square questions as well is they might not say write it in completed square format. They in fact are more likely nearly to just show you this and say write it in the form ax minus p all squared plus q. So you have to recognize that as completed square form. So let's look at this example. First of all, we're completing the square for the following quadratics. So we start off by taking the coefficient of x, which is 7. We're going to divide it by 2, and we are going to square our answer there. So we get 49 over 4. So then taking my quadratic that I have, x squared plus 7x minus 9, I'm going to be adding this new term and I'm going to be subtracting it. So in that way, I'm nearly ensuring that I haven't actually changed the question at all. What I'm going to do now is I'm going to take the part that I've added, and it's always the term that you've added, and we're going to move that closer to the rest of the equation. Okay, taking the 9 out because the 9 is not really useful to me here because it's not helping with completing a perfect square. If I look at this part here, we should hopefully be able to kind of recognize that as a completed square. And if we rewrite it in completed square format, we get x plus 7 over 2. And we should note there that the 7 over 2 was what we got when we divided the middle term in 2. Okay, and that's kind of been our rule in a sense for a completed square, particularly if we look back up at completed square format here. If we have a completed square where this is x squared, then this part here, the part in the middle, is always going to just be 2b. It's going to be 2b. So by dividing it in half, dividing it by 2, we're essentially finding the value of b. We then square it to find this part here so that we can get our perfect square. But you'll notice that in our perfect square format, what's inside the brackets there is the b. So it's half of the middle term. So that's kind of the key part here. When we divide that x coefficient by 2, that's going to be what's in our bracket. That's the b part from our perfect square idea. Now we can't forget about the last little part that we have here. So the minus 9 minus 49 over 4 is going to give me minus 85 over 4. And that's my completed square format for that quadratic. Looking at the next quadratic here then, let me see, I'm just going to give myself a little bit more space for this one because there's a bit more to do. The first thing we need to do is deal with this coefficient here. So we can't do completing the square if we have a coefficient of x squared. So I need to factor that out. 2x plus 4. So we end up with a nice one this time where it factors out quite evenly. Now I'm going to follow the same idea as I did already. I'm going to take the coefficient of x, I'm going to divide it by 2, so minus 2 over 2, and I'm going to square it. Minus 2 over 2 is minus 1, so squared is just 1. So I am going to now add and subtract that within the brackets. Okay, within the brackets. So plus 1 minus 1. Because we're working on completing the square inside that bracket. The 3 has been factored out. We're going to worry about that at the end. So continuing that on, x squared minus 2x, I'm going to bring the plus part over to the rest of the question. I'm going to leave the minus part at the end. Again here, we should recognize this part as being a perfect square. I can use my previous part here, this minus 1 part, in order to help me know what's going in the brackets. So it's going to be the minus 1. I could quickly multiply that out if I wanted to double check my answer. And we're still inside our bracket here. Plus 4 minus 1 is plus 3. And last thing I need to do is distribute that 3 across. So 3 times my bracket gives me 3 on the outside, and 3 times the 3 gives me 9. Okay, so keeping that 3 on the outside until the very, very end when I'm completing my square there. Okay, same thing's going for this last example. Again, I'm going to factor out 5 before I start. Let me just use maybe a square bracket here from the beginning. So x squared minus 2 over 5x minus 8 over 5. So a bit more complicated of a question it looks like we're going to be having here. So let's keep following through in the same way as before. So my first step is going to be to take this minus 2 over 5, and I'm going to be dividing that by 2, which gives me minus 1 over 5, and squaring that gives me 1 over 25. 1 over 25. Okay, so as before, we are going to add and subtract that to my equation that I'm looking to complete. So that means doing it inside the bracket here. So plus 1 over 25 minus 1 over 25. Okay, again, as before, we're bringing the plus version of that over beside the rest of the kind of quadratic expression, and we're going to bring the other constant, the minus 8 over 5, over beside my negative constant there, the 1 over 25. Now again, completing my square involves me writing it as a perfect square, and we know that we can look back at our kind of coefficient where we divided it by 2, which was the minus 1 over 5, because that's what's going to be inside my bracket. So minus 1 over 5 squared. Okay, minus 1 over 5 squared, and I can also work out what the minus 8 over 5 minus 1 over 25 is going to give me, and it gives me minus 41 over 25. So then multiplying across by the 5 there, I get 5 x minus 1 over 5 all squared minus 41 over 5 as my answer. So we're following the same steps every time, but it's really important that you know and understand each of those steps. So I've tried to kind of highlight things there as much as I possibly can. So even kind of noticing that the term that's going to be within the brackets there, that b part of our perfect square, where we've seen that in the question is when we divided the coefficient of x by 2. Okay, that was coming back to this top part where in front of here we have 2ab. So if a is x, then this middle part is just 2bx. Okay, your middle part of your question will always be 2bx. We want to have b squared, so we have to divide the 2b by 2 to get b on its own. That's always what we're trying to do. But if you even just remember it in the sense of this idea here. So divide the x coefficient by 2, square it, add and subtract to your expression, and then what's going to go inside the brackets is going to be the same as when you divided that term by 2, the kind of first thing that you've kind of calculated there. Now, the reason our completed square format is so useful for us, okay, the reason it kind of helps us so much is actually listed in this part here. So the completed square form gives us information about the graph of the quadratic. So for a quadratic in completed square format, so as we've said, they might tell you, they might just give you the format itself. The turning point is the point PQ. Now we have to note there that in the actual question, or in our kind of general form, it's minus P. So that's something to watch out for. The point is PQ, but in the question or in your completed square format, it's minus P. So if you were given a question where it was x minus 3, then your maximum point would be 3 whatever. If it was x plus 4, your maximum point would actually be minus 4 to account for that loss of the minus. Okay. The other thing that's important in that is the leading coefficient a. So if a is positive, then my graph is positive and it will have a minimum point. If a is negative, my graph is negative and it will have a maximum point. So important to look at the version that you're given. Occasionally, if a is negative, the question could actually be written in the opposite direction, starting with q, in order to just not be starting with a negative number or a negative sign. As I've said, we can use this to quickly find the roots of a quadratic and comment on their nature, and it also helps us find the values of x for which a graph is positive or negative as well. So I'm going to go back up to this example here, and they've said using the graph, write the equation in completed square form, and there we're seeing where they're not maybe giving us that idea. They are in fact giving us the maximum point here, so I know that my maximum point is going to be PQ, and for this question that's going to be 3, 4. That's going to be 3, 4. Okay, so subbing just that point in, I get y is equal to ax minus 3 squared plus 4. Okay, we still have one unknown, the a, and what we're going to do with that one is we're going to make use of this other point here that we know is on the graph, which is 2, 2. Now what I'll also say is, looking at the graph, I am expecting that a will probably be negative because my graph is a negative graph. It has a maximum point, so I'm nearly expecting that a would be a negative value. But we're not sure, so let's sub in the point. So we're going to sub in 2, 2 because that is on the graph. So I'm going to sub 2 in for y, and I'm just going to be subbing 2 in for x also. Plus 4. 2 equals a times minus 1 squared plus 4. So 2 equals a plus 4, and that means that a equals minus 2. As I kind of expected, we got a negative answer. So minus 2 x minus 3 all squared plus 4 as my equation of that polynomial there. And as I said before, sometimes we might see that written in the opposite sort of direction, just so we're not starting by writing a negative sign. So starting with q instead of starting with your a there. So let's just look at one or two more of these examples here. So we have another example, and then we have a practice question or two to look at. So let's just look at one of the examples. So write this quadratic in completed square form, state the turning point, whether it's a max or min, and comment on the nature of the roots. So let's just start by completing the square. So writing out my question, I'm going to start by factoring out my minus 2, and I get x squared plus 6x plus 5. Okay, as before, 6 over 2, which of course is 3, we're going to square it and get 9. So x squared plus 6x plus 5, I'm going to add 9, and I'm going to subtract 9 to ensure that I'm not changing my question at all. So minus 2 x squared plus 6x plus 9 plus 5 minus 9. Okay, and minus 2. Rewriting our perfect square here, that's going to be x plus 3 all squared minus 4, and I can distribute out my minus 2 there. And again, I could just maybe flip that around to get it in something that's a bit more similar to what we normally write. We normally wouldn't start with like a negative number like that. We would kind of rewrite it in that sense. So looking, first of all, I'm going to look for my turning point. So my turning point there, as we know, is the point PQ. Okay, and looking at my question here, we know that a general completed square form is something like this. So matching that up, we can see straight away that Q is 8. We know that minus P is equal to 3, And if you even want to just take that out, if minus p is 3, that means p must be minus 3. So my point there is minus 3, 8. Minus 3, 8. Okay? Whether it's a max or a minimum, it's actually going to be a maximum. And the reason we know that is because a is negative. A is equal to minus 2. So because that's negative, I have a maximum point. It has a leading coefficient that's negative, so it looks something like this. To comment on the nature of the roots, we can kind of solve it using completed square form. So if I take this maybe over to one side here, we can just take our completed square form, 8 minus 2x plus 3 squared. We know that the roots are where y is equal to 0, where my function here is equal to 0. So I'm just going to try and quickly solve this for us. So we get x plus 3 squared equal, let me divide by my minus 2, gives me 4. So x plus 3 is plus or minus root 4, which of course is just 2. And I get that x is equal to minus 3 plus or minus 2. So the nature of the roots there is 2 distinct real roots. 2 distinct real roots. Okay, they're not rational roots, but they're 2 distinct, or they in fact are rational roots. Sorry, they are rational roots, because of course we can work that out further. We can get minus 1 and we can get x is equal to minus 5. So 2 distinct real roots. Okay, just a quicker way of us solving, and we're just finding the roots there. Okay, so in a question like that where they've maybe led us through getting completed square form, it just makes the most sense for us then to use that in commenting on the nature of the roots. So let's just quickly run through these last question or two, the kind of practice ones. So here a quadratic equation has a given minimum point, passes through another point, find the equation. So we've already kind of done one of this format. So again, I don't know what A is. I can fill in for P and I can fill in for Q using the fact that I know that my maximum or my minimum point is PQ. I can then use one of the points that I'm given. So that point 0, 7, subbing that into my function, I get a minus 3 squared minus 11. So 7 is 9a minus 11. So 9a is 18, which means a is 2. So let's rewrite the equation. 2x minus 3 squared minus 11 as my overall answer there. Okay, let's look at the last exam question here. So again, I'm going to start by factoring out the 2, x squared minus 7 over 2x minus 5. Then I'm going to take my minus 7 over 2 and I'm dividing that by 2, which gives me minus 7 over 4. And I'm going to be squaring that to give me 49 over 16. So filling that into my question, as we've done kind of countless times here now, I'm just going to jump a tiny bit ahead. I'm just going to place it in there where I want it to be. Okay, I can rewrite then using my perfect square, rewrite it as x minus 7 over 4 all squared. And the minus 5 minus 49 over 16 is going to give me minus 129 over 16. And distributing the 2 across there is going to give me minus 129 over 8. Okay, minus 129 over 8. Hence, write the minimum point. So the minimum point is the point PQ, which is going to be minus 7 over 4 minus 129 over 8. Okay, minus 7 over 4 minus 120, or not minus 7 over 4, sorry, just 7 over 4 minus 129 over 8. They say then explain why f must have 2 real roots and write the roots in the form p plus or minus root q. Okay, why does it have to have 2 real roots? Well, the reason that we know it has to have 2 real roots is if we draw a little sketch of our graph. Okay, this is my minimum point. It's the point 7, 4 minus 129 over 8. Because it's that low down, we're kind of surmising, because we know it crosses the x-axis, it has to cross the x-axis at 2 points. It couldn't have a repeated root, and we know that it does cross the x-axis. So because it has a minimum, value minus 129 over 8, so minimum y value if you like. Because it has a minimum y value of minus 129 over 8, we know it crosses we know f crosses the x-axis. And therefore, it has to have two real roots. Okay, it has to have two real roots. If it had repeated roots, we know that it would be just sitting on the axis there, and if it didn't have real roots at all, it wouldn't even touch the axis. But because it has a minimum value that's of a negative y value, it has to have two real roots. We can find those using our completed square format there. So 2x minus 7 over 4 squared minus 129 over 8. We're going to set that equal to 0. So 2x minus 7 over 4 squared 129 over 8. 129 over 16. And I get that x is 7 over 4 plus or minus the square root of 129 over 16. Okay, and we can't really simplify that one a whole lot further really. We can check it out on our calculator just to be sure. Plus the square root of 129 over 16, and it doesn't really simplify down much further for us, bar going down to 4. So we'll just leave it in that format. We're asked to leave p and q as elements of q, which is our rational numbers, so just to leave them as fractions. So those are our two roots, and we've shown why they're two real roots. So with our completed square format, we can see there's a few different points where that comes in, or there's a few different ways that we can use our completed square format, I should say. So the main point being kind of turning point of our graph. It gives us the turning point fairly easily. We can use it to find or comment on the roots, and we can also use it to talk about the graph being positive or negative. We'll look at that a little bit more later on. But the main thing to know with completed square is that you can do the actual steps of completing the square. That's the main thing to watch out for, that you know those steps, that you can follow them through, making sure you're factoring out the coefficient of x squared, making sure you are dividing the coefficient of x by 2, particularly if it's a fraction, and making sure that you know that this is completed square form. That if a question just said to write it in this form, that you would know what that means. Because as we've seen, there's some questions where we need to use that format and be able to sub in the values that were given in order to kind of answer the question.